What is machine learning? To solve a problem on a computer, we need an algorithm. An algorithm is a sequence of instructions that should be carried out to transform the input to output. For example, one can devise an algorithm for sorting. The input is a set of numbers and the output is their ordered list. For the same task, there might be various algorithms and we may be interested in finding the most efficient one, requiring the least number of instructions or memory or both. For some tasks, however, we do not have an algorithm. For example, to tell spam emails from legitimate emails. We know what the input is, an email document that, in the simplest case, is a file of characters. We know what the output should be, a yes/no output indicating whether the message is spam or not. We do not know how to transform the input to the output. What can be considered as spam changes in time and from individual to individual. What we lack in knowledge, we make up for in data. We can easily compile thousands of example messages, some of which we know to be spam, and what we want is to learn what constitutes spam from them. In other words, we would like the computer machine to extract automatically the algorithm for this task. There is no need to learn to sort numbers. We already have algorithms for that. But there are many applications for which we do not have an algorithm, but do have example data. With the advances in computer technology, we currently have the ability to store and process large amounts of data, as well as to access it from physically distant locations over a computer network. Most data acquisition devices are digital now and record reliable data. Think, for example, of a supermarket chain that has hundreds of stores all over a country selling thousands of goods to millions of customers. The point of sale terminals record the details of each transaction, date, customer identification code, goods bought and their amount, total money spent, and so forth. This typically amounts to gigabytes of data every day. What the supermarket chain wants to be able to predict who are the likely customers for a product. Again, the algorithm for this is not evident. It changes in time and by geographic location. The stored data becomes useful only when it is analyzed and turned into information that we can make use of, for example, to make predictions. We do not know exactly which people are likely to buy this ice cream flavor or the next book of this author or see this new movie or visit this city or click this link. If we knew, we would not need any analysis of the data. We would just go ahead and write down the code. But because we do not, we can only collect the data and hope to extract the answers to these and similar questions from data. We do believe that there is a process that explains the data we observe. Though we do not know the details of the process underlying the generation of data, for example, consumer behavior, we know that it is not completely random. People do not go to supermarkets and buy things at random. When they buy beer, they buy chips. They buy ice cream in summer and spices for glühwein in winter. There are certain patterns in the data. We may not be able to identify the process completely, but we believe that we can construct a good and useful approximation. The approximation may not explain everything, but may still be able to account for some part of the data. We believe that though identifying the complete process may not be possible, we can still delete certain patterns or regularities. This is the niche of machine learning. Such patterns may help us understand the process, or we can use those patterns to make predictions, assuming that the future, at least the near future, will not be much different from the past when the sample data was collected. The future predictions can also be expected to be right. Application of machine learning methods to large databases is called data mining. The analogy is that a large volume of earth and raw material is extracted from a mine, which, when processed, leads to a small amount of very precious material. Similarly, in data mining, a large volume of data is processed to construct a simple model with a valuable use. For example, having high predictive accuracy. Its application areas are abundant. In addition to retail, in finance, banks analyze their past data to build models to use in credit applications, fraud detection, and the stock market. In manufacturing, learning models are used for optimization, control, and troubleshooting. In medicine, learning programs are used for medical diagnosis. In telecommunication, call patterns are analyzed for network optimization and maximizing the quality of service. In science, large amounts of data in physics, astronomy, and biology can only be analyzed fast enough by computers. The World Wide Web is huge. It is constantly growing, and searching for relevant information cannot be done manually. But machine learning is not just a database problem, it is also a part of artificial intelligence. To be intelligent, a system that is in a changing environment should have the ability to learn. If the system can learn and adapt to such changes, the system designer need not foresee and provide solutions for all possible situations. Machine learning also helps us find solutions to many problems in our vision, speech recognition, and robotics. Let us take the example of recognizing faces. This is a task we do effortlessly. Every day we recognize family members and friends by looking at their faces or from their photographs, despite differences in pose, lighting, hairstyle, and so forth. But we do it unconsciously and are unable to explain how we do it. Because we are not able to explain our expertise, we cannot write the computer program. So at the same time, we know that a face image is not just a random collection of pixels. A face has structure. It is symmetric. There are the eyes, the nose, the mouth located in certain places on the face. Each person's face is a pattern composed of a particular combination of these. By analyzing sample face images of a person, a learning program captures the pattern specific to that person and then recognizes by checking for this pattern in a given image. This is one example of pattern recognition. So machine learning is programming computers to optimize a performance criterion using example data or past experience. We have a model defined up to some parameters, and the learning is the execution of a computer program to optimize the parameters of the model using the training data or past experience. The model may be predictive to make predictions in the future, or descriptive to gain knowledge from data, or both. So machine learning uses the theory of statistics in building mathematical models because the core task is making inference from a sample. The role of computer science is twofold. First, in training, we need efficient algorithms to solve the optimization problem as well as to store and process the massive amount of data we generally have. Second, once a model is learned, its representation and algorithmic solution for inference needs to be efficient as well. In certain applications, the efficiency of the learning or inference algorithm, namely its space and time complexity, may be as important as its predictive accuracy. Let us now discuss some example applications in more detail to gain more insight into the types and uses of machine learning.